Question is question number 4, and it's from our review pack. And it has a statement that 3 plus x squared to the n plus 1 is what our value is, and we know that there is some magical term that's n plus 1 to the r times 3 to the n plus 1 minus r times x squared to the r has got to be equal to this 20412 x to the fourth. Well, in order for this to happen, my x has to get to the fourth power. So the question becomes, what value of r makes that happen? Well, the only value of r that can make that happen is that has to be 2, right? So just by doing that, to make those two equal to each other, we've already figured out that this is n plus 1 to the 2, or n plus 1 choose 2, times 3n. Well, I've got plus 1 minus 2, so I've got minus 1. And that's going to be times x to the fourth is the same as 20412 x to the fourths. Well, right off the bat, I can cancel my x to the fourths because I can divide both sides by that. I'm going to go ahead and I'm going to rewrite n plus 1 over, or n plus 1 choose 2 as n plus 1 factorial over 2 times n minus 1 factorial. So those are my values. I can simplify that to n plus 1 times n minus 1 all over n minus 1 factorial all over 2 times n minus 1 factorial. Well, my factorials will cancel, and I will be left with the n choose r part of this will turn into n squared plus n all over 2 times 3 n minus 1 is the same as 20412. At this point in time, my suggestion would be we can graph it. We could simplify that further. We could try to solve this with logarithms, but I don't see any point in doing that. We've got it in a situation where I can graph one side and then graph the other. So on my calculator, I am going to start a new page. I'm going to add a graph, and I'm going to do x squared plus x. Oh, I don't want you to be x. Oh, you jerk. Sorry. New document. No. Add graph. Sorry. X squared plus x divided by 2. And then all of that times 3 to the x. Just got to make sure I got that right. Sometimes I will write things down wrong. Sorry. So x squared plus x divided by 2. And then we're multiplying all that by 3 to the x minus 1. Right, so that is this crazy function here. Looks kind of interesting. If you actually watch it, it actually comes up a little bit there. That's interesting. And we're looking for when that's equal to 20,412. So I'm going to press tab again, 20,412, and then I'm going to have to do some window zoom here. Let's do my window settings. We know that this thing's going to be at least 20,412, so let's go 30,000 and click OK. So all we know is where those two, so menu, analyze graph, intersection, and that appears to happen where x is 7. So our answer is going to be that this happens when x is 7. I'm just going to paste that here, because when you answer a question like this, you should include a sketch of the graph. But that is the general process. You get it broken down till you can get it to it's a situation where you can actually solve the equation, or you can get it to a simplified step. And once you get that, you just graph it, find the intersection, and we'll have our solution. Let me just make sure. Yep, that's all we had to do. Cool. Hope that's